Alright, in this video, I'm going to show how I made my motor mounts. I need to make over a dozen of these for mounting my electric motors. So I needed to mount 12 of these onto the Challenger and came up with a design and fabrication and trying to keep it as simple as I possibly could. So I've done this the right way. This video is not how to do it the right way. I've been wanting to do this since I did my first hydroformed flaps and ailerons back in 2002. And those were done the right way. Went through FAA Part 23 certification, into production, and this is the exact opposite of that. So I made forms out of leftover oak flooring. I redid the kitchen. Had some leftover material. So nice oak material. So I made a form on the table saw, and then that plus a simple jig and actually leftover gym flooring. Between that, I was able to build I think about 14 of these or 16 of them. I made some extras for testing. Able to get a tolerance of 10/1000ths of an inch, which I'm perfectly happy with. And the next video I'll do. This video is just forming and riveting these guys together. Another video I'll do the testing and the mounting of them on the wing. But you'll have to stay tuned for that. So I apologize. I cut this video down. Well, first of all, I apologize because the timestamps on these go back to April. This is work that I did last spring. I'm just getting around to editing the videos now. Sorry about that. But and originally, when I got it together done this morning, it was about 40 minutes long. While that might be good for anyone who's having a case of insomnia, I went down and pared it down as much as I could to about 25 minutes. Still, probably going to have most people watching were going to, go into a coma by about 5 minutes in, and I apologize for that. But so I cut a lot of the details out. I left, I think, the important ones in. Again, this is not the right way to do this. Essentially, is how badly can I do it, or how janky of a setup can I do and still get good parts. I think I definitely pushed that boundary, but I got good parts. I'm very happy with the quality of the parts that came out, and again, getting it from leftover gym flooring and some scrap wood. Literally zero cost was spent on any of the tooling. I just needed to pay for the water jet blanks. I had these done by a Big Blue Saw, and yeah, anyway, enjoy. Up to 600 volts.
Motor repair, take one. These 4 bolts here.
That shaft moves this lever. It's alive! So in keeping with the project goal of using basic tools, this is just a roll-away job site table saw, but still can get accuracy of a few thousandths of an inch, which is more than adequate for what I'm doing. And with just simple oak flooring, worked out well. Then for all the flat patterns, I just did it in SolidWorks and had it done by a Big Blue Saw. I'll throw a link down in the description. Do good prices and good accuracy. I used the parts for laying out the location, and then we went to the drill press. It's one of the things I love about these projects is my kids love helping out in the barn, and the drill press is my daughter's favorite tool, as well as that drill bit. So I wasn't going to do the nipple die attempt, but when she's asking, I couldn't say no. So I have these holes for a very good reason, to locate everything. Normally you'd have a locating pin, but instead I'm actually using a locating wood screw. You need to have these, otherwise you won't really have a chance of it not moving around when you're trying to form it. Screws don't need to be strong or really hold anything in. They're just, as long as they don't fall out. Like I said, normally I would just do it with pins, but so I just ground that down. Like I said, you really only need 2 to locate, but that screw, little screw head snapped off. I just ground it, and I will be using it as a pin. All right, time to start forming. So a bit of background. What I'm trying to do here is what's called hydroforming. Not the hydroforming where you use liquid as or water or oil as the forming method, but instead you actually use rubber or similar plastic that under pressure will form around and act as a liquid. Anyway, I've done this in the past. I've actually designed certified flaps and ailerons using this method. But always using CNC aluminum machined forming ribs. And I wanted to see, I've always wanted to do, can I do it super low buck? So I've got leftover oak flooring. I put some oak flooring in a while back, and I had some left over. And taped them together so I have the right disc. The whole idea is that I'm going to form this, and it's going to bend this around. And if I get enough pressure, it'll actually dimple those. But I don't know I'll be able to do that. First of all, I don't have a hydraulic press. So I'm using this, I don't know, 30-year-old Craftsman wood vise. This is an experiment. This might work, this might not. Really accurately laying things out with woodworking and taking your time, you can do things within 5 thou. And with the help of my assistant, I'm probably within 10 thou on all these holes. But anyway, let's give it a shot. Like I said, never tried this before. I wanted to do this for about a decade and see what happens. One of the things, you don't want to hold things in place. I can, but needs some improvement. I don't know if I'll really be able to get enough pressure with just this wood vise, but woo! Well, that was close. Handle broke, camera came off. All right, maybe I'm trying to do too much pressure with the wood vise, but let's see what happened. Not quite. I need a little bit more pressure, but you get the idea. There's other ways you can do this. I can make another wood form that would push in on this, but the hydroforming is typically the easiest, most flexible way of doing it. All right. Well, that's encouraging. So a couple things when you do forming, see that, is spring back. Now this I didn't actually, because the handle broke, I wasn't quite able to get to the full level that I want. The other thing you can always do is you can always just use this as a buck and just hammer along there. I don't know. The nice thing with this, I don't have a break. This gives a very repeatable, very clean edge there. You can see. Think new handle and then more sheets, but yeah. Like I said, experiment. Almost a success. So I guess I'll just give up. Well, maybe not. All right, second attempt. Old handle. Steel is real. All right. New handle. That's one. That is what's known as spring back. Can't really see it, but the lower one's actually a little bit smaller. Oh, it's best to sneak up on spring back. I think a big part of well, obviously I don't have enough force to fully do it. But this is such thin aluminum, I can always finish it off. So, not perfect. I need to do it with a hydraulic press. Now I made everything symmetric, so last time I bent it like that. These are 2 halves of the same mount. So then so I come in here, see that pin locates it in, and really all I need on this would be 1 screw. But I'm going to put a second one in. Again, normally you don't do a screw here. You would just do a pin. But with my jury rig setup here, the less things I have to hold in place, the better the chance of success. All right, should we try this one? Bigger handle? What do I have? It's a bigger handle. Longer. I could finish them all off this way, or manually. I can make a wood form that just pushes over the side. Don't think I have a high enough pressure durometer to do the dimple. That would be a hard one to do anyway, because you're actually stretching the material to go around a corner like that. So, really need a hydraulic press. All right, so I'm gonna try this again. Got a little bit more foam, but then the key thing is made a box. Well, it's not really a box, but for this shape, it's all I really need. And just like that. So as my son was just pointing out, that we need, the reason why we're doing this is that we need 12 of these, 2 each, so they're identical, so I need 24 total. And I'll add, if this works, I'll add another stop so that I don't need to align this. Get this close first, just to come up. It's the beauty of doing it this method, is I don't need to be exact. That's what the foam is for. Rubber, in this case gym mats, it's doing the work. And because I'm putting the pressure where I need it, not over the entire thing, it's going to require less force. So what was the problem I was running into earlier? All right, should we see if it worked? Mm-hmm. All right. Once I figure out the right spot, I'll glue a block in. Let's give that a shot. Yeah, because we're making 24 of these. Getting this dialed in makes a lot of sense as opposed to hand forming it. And I always just wanted to do it this way before. All right. pushed against the top there. I don't know if it actually show up. Alright. And actually the rubber's gonna creep a little. And another crank in. Alright, let's see what happens. Not quite there, but pretty dang close. No, a little more adjustment, but even just doing it majority of it this way, and then just the biggest thing I need to do, I think, is this is mostly spring back. So when you're forming material, you're actually yielding it, and part of that force that so I can push this all the way against here. I need to come back and undercut it, such that it will allow it to spring. So actually, I'll measure the angle that I have here, and then I'll cut the reverse of that onto this board, and that will be just about the right amount of spring back. Spring back will vary depending on temper and thickness of material, and in some cases actually how long it's sat around. These continue to age harden, especially the T4 and the T6, or the T4 in particular will sit around and age harden. So quite often you'll form it in the T4 position and then heat treat it to the T6, because T4 you can form without it cracking. That's T4. Alright, to set the angle, there's a couple different ways to do this. But the easiest for me is to come in here and just align my blade to match that of my spring back. There. Which in this case is 11.5 degrees. Key thing is, I don't want to change this side. This is the tool surface. I want to change the back side. I'm probably going to sneak up on it. It's easy to take more material off. It's hard to put it back on. Alright. Now we've cut to account for the spring back. Let's see how well this works. The reason I didn't put the spring back initially, I wasn't sure exactly how much it would be. I knew I could do it straight. And then measure it. Alright. Top is perfect, the little guy was saying, but I didn't have it quite positioned right. You're going to need another thing of foam. I've actually overdone it just a bit because I wasn't centered. Once I get the position right, I'll mark it. So I'll put a stop on it so it goes in the right spot. There we go. Now have a formed motor mount.
Half of one.
Half of one, that's right. Sorry. Alright. Shall we take it out and see what happened? See what you can achieve with leftover flooring, gym mats, and hot glue. Like so. If it's showing up at all or not. Problem is with trying to do the back cuts for spring back is that it's not. That's a function of me not having enough, partially not having enough pressure. This stuff should be essentially flowing like it was a liquid. Then I'll rivet and cleco that together, and I'll have an engine or a motor mount, as the case may be. Alright, so I'm adding some more onto this jig. Really the closest, this should be a box to be able to contain all the rubber. But I'm just hacking this together. Yeah. Again, this is excessive. I'm just doing this because I've been wanting to try doing this for a while. Really, this was the only thing I needed to make, and I went a little excessive on that. I'll show you I can do this with just the table here in a bit. But anyway, I want to see the experiment through. A couple of things I want to show is, I actually am a fan of hot glue to help hold things together. So I'm putting these on as guides. Again, if you're having to locate something or measure something 3 times or more, make a jig. And this is just some blocks of wood, hot glue them in place. Get the cheap nail gun to actually hit a nail. But anyway, that will locate everything. And all right, should we see if this works? Yeah. So I didn't screw it down, I just left the pins. Gets it close. Not really.
It's quick.
Not really. Alright, well. Enough playing with that there. Go do something with that.
Once I got it all dialed in, it was just a matter of repeating the process over and over. And you can see it was pretty easy to make the parts with repeat and accuracy. Unfortunately, using a wood vise for this, which is not what it's intended for, had the expected result where it ended up wearing out the lead screw. As you can see, it made it so I had to finish the last one by hand there, but got most of them done. And you can see there where I wore out the teeth there. So I got about 3/4 of the way through before that 30-year-old vise gave up the ghost. But luckily, I had access to a hydraulic press. Now, I know what you're asking yourself at this point. If you had access to a press, why didn't you use it to begin with? Well, first of all, this is a friend's hydraulic press, not my own. And secondly, the whole point was to try out and see what I can make work with as few unique tools as possible. But you can see how much more pressure I was able to apply with the hydraulic press, even using my simple wood fixtures. It worked out quite well, and I was able to use it to finish off the last third of the parts. And the spring back actually remained constant, which was nice. So, having made all of them, it was time to rivet everything together. When you're making 12 of things, it's just good things to get everything set up. Try to make Henry Ford proud. I designed it such that I could kind of interweave things together. No real set purpose for that. It's nice because it holds itself together before you even put any rivets or clecos in together. And I think it looks cool, but it doesn't make it any stronger or any weaker. But felt like doing it. So, yeah, just kept repeating the process cleco together one side, drill out the holes, pull the rivets, and then take off the clecos and replace them with rivets. Pretty straightforward. Loads on these are really, really light, so I wasn't having to use any kind of high strength rivets or anything like that. Oh, and if you guys want to watch a video on the proper way to do this with a press and a box, etc., I think it's Rainbow Aviation has a good video where I think they partnered up with EAA and showed the right way to do it. I'll throw a link down to that in the description, and it's, like I said, the right way to do it in a shop where you're not just gluing together random stuff that you have laying around. This was essentially the lowest budget, simplest way I could do to make it, but I ran out of rivets, unfortunately, when I was making this video, but got it all done, and now they're ready to go on the airplane.
So there it is. I mean, like I said, this is not the video on how to do it the right way. This is how to do it the wrong way, as much the wrong way as possible, and still get good parts, which, again, I made 14 of these. Once I got everything set up, as you see in the video, it was just lather, rinse, repeat, and just, didn't even have to think about it. I got very, very consistent parts. Anyone who's done this before, it shouldn't be a surprise, though, you don't have to go quite to this level of jankiness that I did, but I wanted to see how far I could take it, and yeah, again, I'm happy with the results. So that's for making the motor mounts. It's kind of 25-minute video just to make a dozen of these, but it's more the process behind it. The next video, I'll talk about installing the motor mounts. So I actually, before I installed them on the actual airplane, made up a test piece, bought the same tubing as a spar, structurally loaded that, and learned from that and mounted it onto the airplane. So I'll have to stay for the next video. And also, I've got all the motor testing done. So that's another video that I'm in the middle of editing. I won't take 6 months on it, I promise. But I hacked together a charged refrigerant scale that I got off eBay to make a thrust testing rig, and hope you guys will enjoy that one. So if you like this, if you're still awake, thanks, congratulations. If you like the videos, feel free to subscribe. I should have the next ones out in the next week or two on both the dynamic thrusting, where I strap this to the front of my truck and we drive 65 miles an hour down the road and see what kind of thrust I get, and the installation and structural testing on the actual airplane. So, hope you guys enjoy. Have a good one.